The next class we are going to see about concurrency control. So, what is meant by concurrency control? So all these are based upon transactions only. So what are the transactions we are going to do in the banks? The same thing we are going to take an example here in the concurrency control. So inconsistency of data leads to concurrency control. So if your system or if your bank does not have concurrency control, that leads to inconsistency of data. Let's take a real time example. For suppose I and my friend have a joint account. Joint account is nothing but we both have access to withdraw the cash from the particular account. So what we are doing? So we are going to a bank, same bank in different branches. Now I'm going to withdraw cash in Kompally. My friend is going to withdraw cash in Secunderabad. And the point is, my bank does not have any concurrency control. Okay. So our bank balance is 600. Let's take it as example as 600. So our joint account have balance of 600. So now we want to withdraw the cash. Now we want to withdraw the cash from our bank account. At the same time, I and my friend are going to withdraw the cash from my bank account. So the point is, my bank account does not have any concurrency control. My bank is not having any concurrency control of the database. So at the same time, I and my friend are going to withdraw the cash. So we both are going to have 500 each in our hands by withdrawing at the same time from same account, but the balance is 600. We withdraw the cash of 500. How? Because inconsistency of data is going to be happen. So my bank person may think that I'm only the person who is going to withdraw the cash. He don't know simultaneously the other person also withdrawing the cash. He don't know that. That leads to inconsistency of data. That tells that your bank does not have any concurrency control in database. So what will happen? Inconsistency of data is going to be happen if your system does not have concurrency control. So how to avoid this and how to maintain your database accurately, and what are the problems we are going to face with this concurrency control and how to avoid them. These are the topics which we are going to see in concurrency control. So let's see the theory part. When more than one transactions are running simultaneously, there are a chance of conflict to occur which leaves database into an inconsistent state. Just now I gave an example. What is inconsistent state? To handle these conflicts, we need concurrency control in database management system, which allows transaction to run simultaneously but handle them in such a way so that the integrity of data remains intact. So what is our motive? So we have to provide concurrency control to our database such that whenever two or more transactions are going to be happen at the same time, but still the database should remain same. There should be no inconsistency of data. Okay, these are the goals we have to achieve. So what are the concurrent executions in database? Let's see. So the first point is a multi-user environment. So when you have multi-user environment, there just now whatever the example I gave you, that is multi-user environment. So joint account is nothing but two people are authorized people to withdraw the cash and also to credit the cash. So such kind of executions of transactions are called as concurrent execution. When there is a multi-user environment, when multiple people are going to allow the access and also to withdraw the cash or placing number of requests and also receiving the requests leads to concurrent execution of database. So the next one is concurrent execution. That is nothing but when several operations are going to be performed on a data item in database concurrently. That is nothing but multiple read requests and also multiple write requests, or the combination of both requests are going to place on a database at the same time. That leads to that leads to several issues. Let's take an example. So now we have transaction 1, transaction 2. So transaction 1, transaction 2s are there. So where I want to read the data, where I want to write the data at the same time when transaction 2 appeared, and he also want to read the data and he also want to write the data at the same time. That leads to several of issues, no? So that is also one type. And so what is the goal? So the goal of concurrent execution is to allow multiple transactions to execute simultaneously in such a way that each execution transaction does not affect other transaction in any way. So our goal is that we allow multi-user environment, but the condition is we should not affect what are the transactions we are doing, that should not affect the secondary transaction. So all the transactions have to be occur parallelly. Okay. So collisions or conflicts should not appear. So to do that, we have concurrency control. Before going to see, how we are going to resolve them, let's see what are the issues we face in concurrency control. So basically, we have three problems. If you don't have concurrency control in your database, basic problems which we see are three kinds of problems. The first one is lost update problem. So it is also called as WW conflict, write conflict, or lost update problem. So lost update problem is nothing but if you see here in the diagram, we have a diagram with the transaction T1, T2 and the time as T1, T2, T3, T4, T5 up to T8. So these are the time slots, these are the transactions which are going to be happening. T1, T2 are two parallel transactions which are going to appear on same data. So now A is the bank account. So now I want to read my bank balance. That is nothing but at the time T1 I am going to read the balance whatever there in my A account. At the time T2 I am going to increment it with 100 rupees. Okay, let's assume that my bank account balance of A is 100. Let's take it as 100 when T1 is going to be happening at the time of T1. At the time of T2, I am going to increment my bank account with 100 rupees. What is the initial balance? That is 100. So when I am going to update it, it becomes as 200. Now my A balance is 200. If you see, in the last classes we have observed that whenever you are reading, whenever you are doing any operations on any transaction, immediately we have to write this. If you're not going to write this, it's not going to be updated in your database. So there may be a chances to lose this information. So to avoid such kind of problems, basically we write this A at T3 time only, right? But what is going to be happening here? At the T3 time, I'm going to read my data again. So now my data is reading again. I am going to increment it with 200. So whenever in the transaction T2, whenever I read A, it shows that my balance is 200. Now I am going to increment it again with 200. That is nothing but A is equal to 400 now. After doing T2 at T4 time. At the T5 time slot, if you observe, I am going to write A at T1. But if you see transaction T1, according to the T1, your account balance should be 200. But due to this T3, T4 time gap, it has incremented to 200. Now your value have been changed. Now T1 at the time slot of T5, it don't know what to write. Whether we have to write A as 200 or A as 400. There is a conflict in our database. Such kind of errors are called as lost update problem. Because at the T3 time, we lost to update our database. This is very common problem which we face if we don't have concurrency control. Okay. So this is one problem. So let's see the next problem. If you see here the theory part also explains the same thing. Please go through with this theory part. And next if you see the problem 2. So generally if you don't have concurrency control, the second most problem is dirty read problem. Dirty read problem is also called as WR conflict. What is this? So in the very starting classes, we have seen memory, no? So in that, whenever we are going to store data inside the memory, we have a problem called as dirty read, dirty data, dirty storage. That is nothing but whenever you left incomplete data, you are writing something due to some issues, you left over the data and you come back out of that particular transaction. You remained it, you didn't finish the transaction, you left over the transaction in the middle. Such kind of transactions are called as dirty read. Such kind of problems are called as dirty read problems. So what will happen? See, let's see the theory. So let's see the example first. So here I'm going to read A. Okay, let's assume A is equal to 500. Okay, my bank balance is 500. At the T1 time, I'm going to check my bank balance as 500. After that, I'm going to do it minus 500. I'm going to withdraw 500 cash. So now at a T3, I'm going to write it. So finish. So A is 0 now because initially I have 500 rupees. I withdraw 500 cash. So now when you are going to write it, your bank account balance is 0. At the T2, you are going to read it. So when you read a T2 transaction, A is 0, right? After that, at the time T5, I'm going to credit 100 rupees to it. So now my bank balance is A is equal to 100. Now I have written it. While writing A is equal to 100, at the same time, whatever the transaction you have made in T1, it is failed. Okay, it is failed. That is nothing but whatever you withdraw the cash of 100, that particular transaction is failed due to some network issue, whatever it is. Now, the data is going to be in inconsistent state. Why? If at the T6 this failed is not going to be happen, everything is in a linear motion. But at the T6, whatever you have been withdrawn the cash, that particular transaction is failed. So that whatever the amount you withdraw, that is cancelled. So now again your data. So now at the write A of T6, it don't know whether to write A is equal to 100 or A is equal to 600 because whatever the transaction you made at T2, that is failed. Such kind of transactions are also called one of the problem with concurrency control, and this kind of problems are called as dirty read problem. Okay, in the middle we thought that we finished the transaction, but due to some network issue or due to, so these things in our real time example, if we take real time example, we basically see these kind of transactions when you are doing a phone pay or google pay to any transaction. So first it will debit the balance. For suppose it will debit the balance, but still the shopkeeper didn't receive the money, but the amount have been deducted from your account, but still he didn't receive. That is inconsistency of data. You in your mobile phone, it is very clear that the transaction is finished, but to the shopkeeper, he didn't receive the amount. So this is a dirty read problem. This is a dirty read problem. So maybe now it is resolved, like after 5 or 10 minutes, automatically whatever the amount have been deducted, it will be credited to your balance account. That is resolved. But such kind of problems are called as dirty read problem, and the same theory part is there. Please go through with theory part. Whatever I explained now, the same things will be there here. And the third very common problem which we see with this concurrency control is non-repeatable read problem, and it is also called as a WR conflict. So this conflict occur when a transaction reads the different values for same data item. Such kind of errors are called as non-repeatable read problem. So when you are going to check your balance, first time it will show you as 1000. If you check after 5 years like that, if it is going to show 500 rupees, the same bank account, you didn't did any transaction, but it is showing two different values. Such kind of problems are called as non-repeatable read problem. If you see the example, we have two transactions as T1, T2. So in the T1, at the time of T1, I am going to read my A account, and it reads that my account have 100 rupees. After that, at the T2 time, I'm going to read it again with the transaction T2. Some other T2 person came and he want to read my account balance, that is 1000 rupees, and he is going to deduct, and he written, and if you check again your bank balance, it is going to be deducted as 500, and you don't have any intimation that you have been withdrawn the cash of 500 rupees. So this is one more problem. So you did anything, but after some time you are going to see some other number of balance. Like, see, at the 1 o'clock I checked my balance as 1000 rupees mark. After half an hour, if I'm going to check my bank balance again, it is deducted to 500 rupees. I didn't do any transaction, but still it is showing like that. That is corruption of data, no? That is inconsistency in the data. So such kind of problems are going to be called as non-repeatable data. A non-repeatable read problem. These are very rare. These are very rare. And why these kind of problems are going to be appear? Because your database does not have any concurrency control. These are the normal problems which we see if your database does not have any concurrency control. Now let's see what are the protocols or what are the things we are going to handle to reduce them or to handle such kind of issues. How we are going to control, let's see. So basically, so let's see the theory part. So concurrency control is a technique that ensures that the above three conflicts does not occur in the database. There are certain rules to avoid problems in concurrently running transaction, and these rules are defined as the concurrency control protocol. So what are the issues we have seen up to now? The three common issues. We are going to control them by using these three protocols. So what are they? One is a log-based concurrency control protocol, and second one is timestamp concurrency control protocol, and third one is validation based concurrency control protocol. Let's see one by one. Log based protocol in DBMS. So log based protocol in DBMS is nothing but basically up to now we have just seen the transactions. We didn't see any log systems. So log system is nothing but we are going to isolate that. So whenever I'm going to perform a transaction, no other transaction should interfere in that. So no other transaction have any rights to do any modifications. So such kind of things are called as locks. And also here we have two kinds of locks. One is shared lock and second one is exclusive lock. Shared lock is going to be represented by capital S, and exclusive lock is going to be represented by X. So shared lock is nothing but, so if you see the theory part, the same thing will be there. I'm going to explain now. So shared lock is nothing but, here you can read the data. You can only read the data. So if your bank have shared lock, that is nothing but anyone can read the data without any authorization rules. Okay, you can read the data. Exclusive lock is nothing but, here you can read as well as you can write the data. Okay, you have a capability to read and also to write the data. So two types of locks we have. One is shared lock and second one is exclusive lock. Shared lock is nothing but you can read the data. That's it. You can't modify data here. But if you have exclusive lock, that tells that you can read as well as you can write the data in your system or in your database. Let's go over the theory part. So shared log. Shared log is placed when we are reading the data. Multiple shared logs can be placed on a data, but when a shared log is placed, no exclusive log can be placed. So what he is telling, with one bank balance, with one bank account, you can place number of shared logs. Whenever shared lock is performing on your account, no exclusive lock is applicable to it. After performing share locked only, you can perform exclusive lock. You can't do parallelly both operations. You can't do at a time. So n number of shared locks can be applicable, like 10, 12, how many locks you want to put on your bank, that many you can use by using share lock. Whenever share lock is in action, exclusive lock should not come at the same time. To understand lock mechanism, let's take an example of conflict. So same conflict will be there. Please check that. And let's see the solution, how to solve the problems with the share lock. For example, when two transactions are reading Steve's account balance, let them read by placing shared lock. But at the same time, if another transaction want to update his bank balance, it is not allowed. It is not allowed because Steve account balance, we are going to read it by shared lock. When shared lock is in the action, no exclusive lock should appear in that particular transaction. This is a condition which we are going to apply, because if we apply this, no, most of the problems are going to be resolved. So next exclusive lock we have. So exclusive lock is placed when we want to read and write the data. I explained just now. This lock allows both the read and write operations. Once this lock is placed on the data, no other lock can be placed on the data until exclusive lock is released. So whenever exclusive lock is in the action, no other lock should do operation on that particular bank account. Same as a shared lock. Shared lock was the same, no? When you apply shared lock, no other exclusive lock should be appear on this. But here in the exclusive lock, whenever you are dealing with exclusive lock, no other lock is applicable to the bank. After finishing this exclusive lock only, other locks can be applicable. Okay. So for example, if you see here in the chart, in the matrix, we have two rows. One is S means shared lock, X means exclusive lock. So shared lock can be applicable. Shared lock, exclusive lock is not applicable. Wait a second. Is it pointing? Is it pointing? Yeah. So shared lock we can apply. But shared lock, exclusive lock is not applicable. Next. Exclusive lock, shared lock also not applicable, because you can place two or more shared locks at a time, but you can't place one shared lock, one exclusive lock at a time. Okay, coming to the exclusive lock, when exclusive lock is in the action, no other lock is applicable. So now exclusive lock, shared lock also not applicable, exclusive lock, one shared lock also not applicable. Okay, so these are the things, and we are going to see types of lock protocols which we have. So let's see what are the types of lock protocols we have. The first one is simplest lock protocol. Simplest lock protocol is nothing but, let's see the theory part first. This protocol is simplest form of locking the data while the transaction is running. As per simplest lock protocol, any transaction need to occur the lock on the data before performing any insert, update or delete operation. The transaction release the lock as soon as it is done performing the operation. This prevents other transaction to read the data while it's being updated. So the thing is, if one lock is in the action, no other lock is applicable to that particular database. Okay, now see, for example, I want to insert weekly marks of DCE. Now I'm going to update DBMS marks of DCE students. Now no other lecturer can't do any operation in that particular portal of the particular department students, because I am in the action. That is simplest lock protocol. Okay, the second one, pre-claiming lock protocol. Pre-claiming lock protocol is nothing but whenever I want to do any modification, if you want to insert data, update data, whatever the modifications I want to do, I have to collect how many locks are needed to this. How many exclusive locks needed, how many shared locks are needed. I have to collect it in the beginning only. Okay, in the beginning only I have to collect all the locks and I have to perform the action. After performing the action, I have to release the locks. See, you have to occur the locks in the beginning. In this you are going to perform action. In this you are going to perform action. After performing the action, I am going to release the locks at the end. In between these two, no other lock is going to be happen. We know that. That's a basic problem. That's a basic rule we are going to use here. And next, we have two-phase locking protocol. One more mechanism to control these kind of issues. We have two-phase locking protocol. So here at the two-phase locking protocol, we have three phases. Okay, basically we have three phases. If you see here, growing phase and shrinking phase. Let's see the theory part first. So growing phase is nothing but here the logs are occurred on the data item, but none of the occurred logs can be released in the phase. So whatever the logs you are performing, they are not released. In the growing phase, we have to take whatever the logs we needed. In the shrinking phase, we are going to release the logs. We are going to release the logs, whatever we hold. We are hold it. So if you see here, T1 started, transaction started. So we are going to receive all the logs, whatever we needed. Here in the log point, I'm going to do the action. I'm going to do the action. After this performing of the action, this is a shrinking phase. After finishing my job, I'm going to release the logs. So in the like this, I'm going to release the logs whatever I have been holding. This is two-phase locking protocol. And let's take an example. Let's take an example to understand how two-phase locking protocol works. In the following example, there are two transactions, which is T1, T2. Here, T1, T2 running concurrently, which are running simultaneously. So transaction T1 in this example, growing phase is nothing but, see, this is a growing phase. Okay, here to here is a growing phase, because this is the last log which I have occurred to do some modifications in my data. So this is the last log which I received, which I am holding. After that, this is the shrinking phase, because I'm releasing the data. This is the releasing the data. Up to here, whatever the logs I holded, everything I'm going to release now. So this is growing phase. This is up to here. This is growing phase. Growing is nothing but the logs which you are holding, and when you are releasing the logs, no, they are called as shrinking phase. These are shrinking phase. Okay. In the transaction T2. In the transaction T2, if you see, from step 2 to step 10, up to here we are holding logs, no? Up to here we are holding logs. That is nothing but T2 up to hold it here. If you see in the step 11, 12, 13, we are not going to call it as a growing phase, because we are unlocking, we are releasing the logs whatever I hold it. So up to T10 they are growing phase, and this is shrinking phase. So for example, if I have lock in step 11, if I have lock instead of unblock, if I have a lock as A, this also comes under growing phase only, but the condition is that here I don't have that. So my transaction is going to be finished up to here only. So these three are called as shrinking phase. Shrinking phase is nothing but whatever the logs you have holded, you have to release here. Okay, these are the two phases, but the third phase is lock point, where we are going to perform some actions. This is two-phase. This is two-phase locking protocol, and those are the phases which we are going through. And the fourth one is strict two-phase locking protocol. Strict two-phase locking protocol is nothing but, let's see the theory part first. So these are the same as a two-phase locking protocol only, but there are minute differences. So it is also similar to two-phase locking protocol, except that it does not have any shrinking phase. So shrinking phase is not going to be there here. And whenever you are going to hold it, whenever you are going to hold any key, after performing the action, you are going to release it there itself. Okay. If you are going to hold any key, after finishing that particular operation, you are going to release it there itself. You are not going to hold it up to the end of the transaction. You see here what we did. We holded the logs up to the finishing. అంటే ఇక్కడ నేను ఒకటి లాక్ హోల్డ్ చేస్తే ఇక్కడ వరకు నేను దాన్ని హోల్డ్ చేసుకునే ఉన్నా. Okay, this is two-phase algorithm. Whenever I'm going to hold here, if I leave this lock here itself after performing my action, if I leave here itself, that is called as strict 2PL. Okay, but that is not there in 2PL. That is there in strict 2PL. Strict 2PL lo, after na action ayipongane, I'm going to release the lock there itself. I'm not going to carry it throughout the transaction. throughout the transaction we are going to carry in 2PL. In strict 2PL, we are going to release there itself. So this protocol release all the logs only after the transaction completed successfully, and use the commit statement to make the permanent. Okay, after doing that, we are going to make a commit operation so that the changes are going to be done permanently in your database. This is concurrency control, and these are the protocols which we used in concurrency control. And next we have deadlocks in DBMS. So whatever you have been seen in the operating system, the same deadlock operations are going to be there here. So same preventions, but now I will explain what is data recovery. I will explain data recovery. Okay. Okay. Data recovery is nothing but whenever we are doing any transaction, if there is any hazards, if there is any natural hazard or any human errors, due to that we are going to lose the data. No? So how to roll back them, or how to back up the data whatever we have been lost. So for that we have two parts to data recovery. We is classified into two parts. One is rolling forward and rolling back. Rolling forward is nothing but redoing the records. So and rolling back is nothing but we are going to, it is store applies the rollback segment to the data files. It is stored in transaction table. So by seeing this, it will be clear to you. Wait a second.